Hello everybody. Today we're going to be working on a Sunn concert bass head. This is a transistorized amp, so this is something that I do not do very often. I've taken this one on. This has been owned by the same person since the early 70s, and this amp recently started to make some noise, some strange noise coming out of this amplifier. They stopped using it, brought it to me. We're gonna go inside this amp, we're gonna take a look and see what's going on. I imagine it's probably gonna need some power supply work. Some other work might need to be done on this with regard to resistors, possibly transistors. I don't know. It's a little different than what we usually do. So let's get started. First observation, I've got a date code tested on April 13th, 1973. Second and immediate observation is all of these resistors looks like they sat in these clasps right here. See this? And there's a clasp, and this is connected to a heatsink, and it looks like all of them have come out of this at some point and just not connected anymore. May have come out years ago. I want to clean up the resistor and see if there's like a bite mark here that would confirm that they were in there. Check on that. Maybe put a little thermal conductive grease on there. You know, if they test out good, put them back on there. That should be very helpful. We'll see how many watts those are. Those look substantial. Next observation, oh dear. Don't need any words to talk about that. We could see that the electrolytic capacitors are past their prime, especially here. These are good ones. These are Sprague Adams, but this is like, okay, what, 45 years old? Time to go. So it's got to be replaced. I'm just gonna say that all of the electrolytic capacitors here are probably gonna need to be replaced. I could go through each one and check, but generally when the time has come, the time has come. Look at these bad boys. I'm gonna have to find replacements for these. I can tell you that whatever the replacements are for these, they're going to be a lot smaller, so I'm gonna have to source them. I have to find out what the values are first. There's the bridge rectifier, and if I look over here, looks like I see two more rectifiers. Somebody's been in here at some point to replace one of these capacitors. So these capacitors have already started having problems. This is not the way I would have done it. This is going to be swapped out too as well, so it doesn't matter. And these give me cause for concern. We can see all of the transistors in this unit are socketed, but if any of them are bad, they're going to be a bit difficult to find the actual replacements for them. I'm not in the market for transistors, so I'm going to have to do some homework if they are a problem. I didn't say that they were. These are some beefy resistors right here. I want to clean them up and see if any of them are brown or deteriorated. See if I could get a value off of them without having to remove them from circuit too. I hope so. Maybe with the capacitors removed, I could do that. Little connections could always benefit from being removed. A little bit of little dab of deoxit and then connected several times always cleans up those very nicely. And the same could be said for the potentiometers down here. There's a dual right there, but those, see a little deoxit, they clean right up too. It was explained here that the original piece was a breaker and the customer has changed it out for a fuse, and they're good with that. I'm going to leave that change alone, but I confirm that. The first thing I'm going to do is collect all the capacitor values. We're going to do a cap swap. We're going to go and investigate if these resistors should be repositioned, and then we're going to check some values on those. So that's what we're going to get started with. Blow out some of this dust before I continue. I actually use a compressor for this, but it's too loud to demonstrate in the video. I've inventoried every single electrolytic capacitor here on the amplifier so far. It was a white dot with white out. That way I know what it is, but I could scrape it right off with my fingernail. It's not permanent. Except for this one. I gotta find out what this one is. I'm gonna check the schematic against this one, and these two right here I have to loosen to find out exactly what they are. I'm slowly compiling a list in my book so I can make an order. I'm also gonna cross-reference this with the schematic to confirm I have the right values. In looking at my supplier, some of these sizes for the capacitors are kind of funky. Not unobtainable, but not cheap. It's like $35, $40 for that cap alone. This 1000 at $75. Also no slouch, like 20 something dollars. Spoke with the owner. While I'm able to source these items, I'm not able to source all of them from the same supplier. And what we decided was, at least to keep costs down, to run through real quick with the ESR meter just as a preliminary test. But what I'm going to do with these two that is not going to be in my order yet is I'm going to disconnect it from circuit. Then we're going to do a leak down. So we're going to actually get tube equipment on the bench after all. And I ran through these and several of these were a little bit high outside of their parameters. Again, it's okay because I do have replacements coming in. I'm not really concerning myself with caps I'm about to rip out of here. I want to talk about these. We're going to do that now. Right, from an ESR perspective, I don't see any problems. Just preliminary test. This 1075, we're looking at between 5 and 6 ESR. They're around in parameters. So these are showing also good for ESR. Hit these with some solder just so it'll flow. Something I generally wouldn't have to worry about with tube equipment. But with solid state, I have no idea what my leak down tester could do. Blow out transistors from here to the end of the amplifier. So, disconnect it from circuit. Set up to the capacitor here. I'm monitoring the voltage on my oscilloscope back there. I got this one all the way up to rated voltage. Again, hard to test because of the size, but I do believe that this one is probably safe enough to operate. So we're going to go with that. We'll be able to test it in circuit, see how filtration works on it, see if there's any anomalies in it, and we're going to move on to the next one. Start off with the second one. Much quicker. See how quickly the scope is climbing up. Just not let it exceed 75. I'm just going to let it sit there for a while. It's about 73 volts DC. This one also proved to be good enough for running in this amplifier that we'll be able to test it in circuit. It was able to run mini lytic up to 50 volt rating. So that's good enough for me. I'm going to measure some of the beefier resistors. I got one right here. This is a 22 ohm, 5 watt. I'll note these cables have 0.4 ohms of resistance in them. It looks like we're seeing about 26 ohms. So that's about right. We'll move on. All of these big resistors along the back, 1, 2, 3, 4, 0.27 ohms, very small amount. I'm going to see if I can measure it with this or if I have to break out the impedance bridge. I'm going to try this first. And again, looking at 0.4 in the cables. So I'm going to add on to whatever that is to get the resistance of these resistors, if I could get a good reading. So we're going to try it out, see what I can get. So I got 0.7. That seems about right. Yeah, I'm going to say if it's 0.7, it's pretty much on the money. I'm going to move to the next one. It's like 0.75. That looks good too. Just over 0.8, again with intolerance. Finally, our last one. That one does show to be a touch higher. And that one's showing just over 1 ohm, maybe 1.5 ohms. So I have to take a look at that one possibly. I may be getting a little ahead of myself, but as far as the specification goes, that one's a little bit high. I don't go this crazy with resistors, but given how small these resistors are, I find it necessary to break out the impedance bridge to check my work from the multimeter. So what I'm going to do is I'm going to find out exactly how much resistance is in these cables. Okay, in these cables I'm seeing 0.6. I'm only going to connect to the first one. I'm not going to bore everybody with this. We're going to go through this one, and then I'm going to pull the results of all of the rest of them. See how close I got. I'm seeing a reading of 3.7. Subtracting the value gives me a reading of 3.1. And in this multiple gives me 0.31 ohms. So that's the first one, is 0.31. I'll do all the rest now, just like that. So here's what I ended up with for the 0.27 resistors, and I'll put up top here to see how close I got. 0.31, 0.33, 0.40, and 0.50. We'll see how I did. Parts have arrived. The first order of business will be to disconnect only what is necessary to gain access to the underside of this board. A lot of these connections are extremely fragile. A lot of them have already been replaced with soldered connections because these pins have broken off. I don't want to do any more damage than has already been done. Also, I'm going to need to remove enough that when this 4 capacitors are replaced, that I have enough room to work to replace all of these broken standoff. See, that's how brittle it is. Replace all of these broken standoffs with a new nylon setup. So I have taken pictures of the wire connections so that I can remove some of them that I know, look at that, there's another one, that I know are impinging this board. Some of the main offenders are the connections off of the transformer right here. These will need to be desoldered. Might as well get right underway with that. And as I come up, I'll find the next things that are getting in the way and remove them delicately, as I've mentioned, already documented. I might have enough room to do the job. We're going to give it a go, at least for the top two, and if we have to remove more cables, we will. Trying to do a minimum of interruption as possible. I have to clean up this mess here before proceeding. Okay, it's cleaned up nicely. I'm going to go with a fit like that. It's not going to fit in the holder, but we're going to surface mount it. So it'll sit just like that, nice and secure. I'm just going to solder it in. These are the exact same ratings. We can see what technology does over the years to the size of capacitors. First one done. So now I got all 4 caps replaced. The board's also cleaned up. I'll give the soldering iron a break while I make the new mounts for this board, tearing out the rest of the pieces of the old mounts. At which time, once this board's properly mounted, the resistors could all go back in, and the cables will all be reconnected, and then we'll move on. I'm going to put the feet in. I measured the old feet, managed to get enough of one of them together to find out they're about 2.5 centimeters, and this is a 2.5 centimeter standoff. It got a washer, nylon nut on the bottom, so they're going to stick out from the bottom like so. I'm going to put all 6 in, and then a nylon screw and washer up top should seal the deal. You do that now. So I've got this one torqued down on the bottom. You see the board sitting there right on top. That'll be the height, just like original. Do this 5 more times, we'll be set. I've got all 6 standoffs now in the amplifier. We can see front and back. I can now situate this board into position. We'll sit over the screw holes. Can now put the screws in. I did forget to mention, each hole will need to be very lightly reamed to M4. They're just slightly too small by like 1/1000th of an inch. So I'm just going to ream it out ever so slightly and test it, see if it's good. See, now that one's fine. And now I could just tighten these down. I can now reconnect the cables that have been disconnected. I've got this side's connections back in place. Now the cables are reconnected on this side. I'm now going to put the resistors back into their positions up here. Not much with regard to service loop. And there they are. Everything now mounted and secure. That ends that portion of the project. I have it brought up on what is its initial smoke test. Not very interesting to watch on a transistor amplifier. I have a speaker plugged in here for the impedance matching of the output. Right now it's quiet. It wasn't that way. I'll tell you right now, the pots are all dirty. They've gotten better as I've worked them, but that's dirty. Yeah, that one's scratchy. I'll clean the pots. I'll get to those when we work on the other board. But I also heard some thunder in here. Gave me cause for concern. I also found this cable right here is broken. And it was just loosely connected. And that could cause some issues. So I'm going to fix that cable as well. We also have the capacitors to replace, so I'm going to do that now. Loosen all these screws so these knobs could come right off. Have to remove these lugs. And this is missing a washer. Somebody's been in here before. And this one has an extra washer. I've disconnected only what was needed to flip this board upside down. Upgraded most of the capacitors on this board. We're going to turn our attention to the pots now, clean them out with some deoxit. Deoxit's been sprayed in. I've been working these. They seem to be clearing up. I think it'll be okay. This one's a little tough. This is double. Flip it around. We'll put it back in. We'll see how it works. Board is back in. Everything's tightened down. I'll put the connectors back on. Now I'll reconnect all the connectors. Everything is now reconnected. With that, I think we're ready to re-smoke test this amp. I'm gonna be doing cold start into a speaker. I'll be cranking up the volume. These are the type of jacks that they short to ground when nothing's plugged in, so we're gonna be just listening to the amp itself with the inputs shorted to ground. If there are any artifacts, I'll have them recorded, and if not, there'll be nothing to hear. You'll notice that the thunder gets lower with the volume, louder with the volume, and the more I use the amp, the worse it gets. I think the big takeaway here is it's before the volume. The volume comes into Q3, and what we're going to do is we're going to start tracing back Q3 to the grounded input jack. We're going to find out which one of these components is the noisy component. I've traced it to this next location. This is C107, R114, where they converge. Whatever that cutting out is doing right there, it's quiet, it's going to bounce back. Just like that. Again. The question is there... Let's see if the sound wall does that. Yep. During that time, there is input. I've got the signal tracer out, and as I bring it up, this is the coupling capacitor coming off of that transistor to the next junction by R114. And listen to this. But not on the other side of it. It's perfectly quiet. And clean. I'm going to be doing the final test in noise test mode, and as such, I've removed all transistors as well as all connections to the other board. In case I slip up, I don't want to blow out any of the solid state circuitry. This is right where we stopped. This is the area of suspicion. Remember, this is on noise test mode. I just want to show what a short sounds like, so I'll do that now. Nice and quiet. And now I'm going to go through that capacitor. This one's definitely noisy. Same crackling. So here's that capacitor I pulled out of circuit. We're going to hook it up to noise tester here now, turn it on. And we can hear the exact sound coming through the amp. Slightly different quality, different voltages, but there it is. There's our culprit. So I put in a 0.01 microfarad capacitor polypropylene in its place. This is a temporary installation just to make sure that that solves the problem, so I don't waste the capacitor. I'm gonna hook up all the wires and then put the transistors back in. Everything is reconnected. We'll get to give it a go. Jump the volume. Check the input a sec. There's our input. We are dead quiet. What I'm going to do is I'm going to let the amp run about 10 minutes. 10 minutes later, quiet as a church mouse, I'm going to permanently install the capacitor. I'll give it one last test, having permanently installed that capacitor now. Everything is fine, so I'll be reassembling the front board. I've got the amp hooked up to the Fender speaker here for testing. We're just going to do some no noise. It's connected to a guitar, so we just hear the guitar pickups. We did the shorted before. Here's treble boost. Treble boost off. Give it a strum. That's working. Bass. Mid. Treble. On this amp, 2 is sufficient for this speaker. Whatever it is, it's working though. It's clean. No more artifacts. Safe to use. Right? Wife is nodding approval. I think we're done. So I hope you enjoyed this video on the repair of this Sunn concert bass transistorized bass guitar amplifier. Thanks for watching.
Thanks for watching. Would you like to reply?